Hello everybody, I welcome you all to this short tutorial in which we will design a 2:4 decoder using Tana tools. And before we actually proceed, I request all of you to go through my tutorial which I designed before. It's regarding the logic or the concept behind how do you design CMOS circuits. I request all of you because I think most of you have some problems regarding memorizing all of the circuits which are present in our lab record, and perhaps that is the reason why many people were not happy with the part B kind of thing. But there's a very simple concept or simple logic behind these circuits, and if you learn that logic, on which I've already made a tutorial and that is available on my YouTube channel, I'll be sharing that as well. So if you go through that video, then you will be able to understand that designing CMOS circuits is actually something very easy. So that is the key to this video, because if you do not know the circuit, then how would you design it at the first place? So let's start first. We are going to design a 2:4 decoder, and that circuit is something like this. So if you observe, we have four similar circuits like the NAND or NAND, it's similar to the NAND gate. So first what we'll do is we'll design an inverter, we'll keep it aside, we'll design this part, then we'll keep it aside, then we'll be instantiating the inverter in wherever it is required, and you will see how we go through the process. So let's open the SLD, and I think I won't be speaking for much time because you can see how I proceed through the video. I will be only speaking when there's some explanation needed. So we start by the design name and we give the location as to where we need to create the folder. I'm selecting the Tana tools files which is present. I'll be pressing OK, and I'll be designing the decoder. Okay. So we have the decoder. Now we have to start adding libraries. I'll give the location of the library. It would be present somewhere in my documents folder. Some Tana tools, libraries, all. So adding libraries takes some time. That is the reason. Yeah, okay, we have the libraries with us now. We go on cell, new view. We select schematic here. It's very important. We give if you want to rename the cell, you can rename, press and OK. So we have the workspace ready with us now. First we will be designing a simple inverter. So for that we would need the devices. So we select the PMOS first, click on instance. Here it is very important to select the 4-port PMOS. Putting it here, then we will select the NMOS. There is a kind of lag in between. Okay, so click on them. There's some problem while we select the devices, so please don't panic. This problem will be avoided. Okay, so what we have to do is select NMOS as well. We have to instance it here. Okay, we are done, I think. Okay, so we have both the PMOS and NMOS, and now we'll be using this wire in order to connect these two in between. Actually, there's some problem with the software, and that is the reason why it lags in between. Sometimes with that is only at the initial stage. I hope this doesn't happen while we write our exam. So we use the wire in order to connect. And keep this in mind that it is very important to design an inverter whatever circuit you get, because inverter is used almost in every circuit, be it a full adder or a half adder or a decoder or a multiplexer. So the fundamental step which you need to do is to design an inverter at the first place. So we have the devices with us, we have connected them with wire, then we choose ground, click on instance. We have the ground with us now. Then we choose the VDD. We have the VDD with us now. We click on wire, we connect. Okay, and now you see the lag problem which we had at the initial stage is now gone. Alright, so we take the input port. You can press the R letter on the keyboard, which makes it rotate. Why isn't it rotating? You can move this in. You can also rotate from here. That has a problem. Okay, so I'm rotating it by pressing the R key, and then we can take the output port. Then we connect both of them using a wire. Alright, that completes the basic inverter circuit. Now you have to first press escape so that this node goes. Then you can go on cell. You can update symbol. The version which we have in lab actually says generate symbol. Update symbol or generate symbol doesn't really matter. So click on this, and this we have a box. Now you can give a design of your own choice, but that consumes time, so I'm leaving this at this place. This is our inverter which we now keep it aside. Now we again go to the cell for new view, and here we can choose schematic. Start with our NAND gate, if you want to name it NAND gate, because first we have to design this part. Then we can use this part and create similar parts. I mean, in the final decoder workspace, then we can bring the inverter circuit there as well. So now we design a NAND gate by having two PMOS. So let's go to the devices again. We take the NMOS, we instance the NMOS here. There's some problem with regards to the selection. When it comes to selecting devices, then this software has a problem. I don't know why, but anyway. Okay, yeah, so we have one more NAND with us. There's the down key on the keyboard. Now to go down. I'm sorry for the lag which is coming in between. Okay, so we have both NMOS with us. Now we go for the PMOS. This lag comes only while we select the circuits, as I told earlier. Okay, so we go on the PMOS. That's the PMOS. This is wasting time, I guess. Okay, so we can select the PMOS from here as well. We take the PMOS, we put here. And we put it at this place as well. Yeah. Okay, we have both of them now. Oops, we have selected the 3-port PMOS. I have to delete this now. Right now we have two PMOSes in the pull-up network, and we have two NMOS in the pull-down network. We connect both of them using a wire, and we connect here. Alright, and we connect this part as well. this part is also connected here. Why isn't this working properly? Okay, fine. Then this we connect it here. What's the problem exactly with this software? It lags a lot. Alright, so now we connect this. Okay, finally we are done with this. Now we connect the and. First we need to deselect the wire. Then we go with the MISC to take the ground, instance, get the ground, and then we take the VDD, connect it here. So we are done with this basic NAND gate circuit, if you want to call it. Then all we have to do is to attach the input port as well as the output port. So the input we have to put somewhere here. So VA, I'm gonna call it, and here as well. So also VA. Okay. Then we have to select the B. B thing as well. I think we don't need to put the output port. The reason being that is that, and wait, I'll show you the reason for that. Here we do not have an output port to this because the output should actually be somewhere here, I guess. Or wait, why don't I have an output? Okay, I'm sorry, actually there should be outputs here as well, which I forgot to mention. Here, and an inverter is supposed to be connected here, which would be our Y3 if you want to call it. This would be our Y2, Y1 and Y0. If Y2, Y1, Y0 and Y3 are the outputs. So there should be an inverter connected here, here, here and here. Okay, so for that all we need to do is go back here and we need to connect an output port. Yeah, and we attach it somewhere here. Okay, then we can connect the inverter which we have, because all of these circuits require the inverted kind of output. So if you connect at one place, then we can copy paste everywhere. So what we have to do is go back here, instance. So we have done the instantiation. Actually, we have to remove this. We have to connect a wire from here. And disabling the wire, we need to connect the output port. Okay, now we are done with the basic NAND circuit. Like we are done with this part. Now we have to make similar like this, which can be done in the another workspace which you will be seeing.